One thing, I know Bruce King's going to be on a Zoom presentation. He's an engineer from the US, and I was paging through his book, and I started out in the straw bale movement, and so straw is really one of my, what excited me in the early days. But now, we're all natural builders, I think. But here's just one quote from his book. If we took all the straw left over from growing our food, 2 billion tons of waste straw annually, and turned it into durable building products, which we know how to do, we could negate almost all of the 4 billion tons of emissions from making our 10 billion tons of concrete annually. Let's now look at how we can do that. So that's his book, but hopefully we could see a little bit of that here. So, so this is called Top 10 Energy Saving Building Strategies. Our buildings use a lot of energy, and about half of the building, the energy that we use in the U.S. is in our buildings. And about half of that is in heating and cooling. So I've written a book called The Hybrid House, and it really is about energy efficient buildings that use renewable energy systems. This great little sketch is from an architect. You'll see more of his work later. His name Werner Schmidt. He calls this the autark house, and he believes that we should have buildings that don't require any energy, just good design. So I think everyone here knows the trade-offs between conventional and natural materials, including the embodied energy, the healthy qualities of the materials, the locally available materials, and so on. But there are trade-offs because conventional builders don't really know how to work with them, and building officials don't always know how to understand the buildings, as Graham has pointed out. And I kind of need to see my slides, so I'm going to move over here a little bit. And but we want to live in healthy homes, as Athena has pointed out. We want what do we need from our homes? We need, of course, shelter, but we also need to live in a healthy space. One of the wonderful qualities of natural materials is that they are low in embodied energy, and you can find them locally. Straw, for instance, is super low in embodied energy, especially compared to other insulating building materials. Yeah, isn't that amazing? That's a really amazing statistic there. I'm a big fan of insulation but understanding our building materials so that we can use them appropriately. So insulation isolates us, as the Europeans say, from the external temperatures, and then mass stores that energy. So it's ideal to insulate your mass. And as Athena has shown, her whole presentation was all about the beauty and the aesthetics that you can achieve with these natural materials. With these thick building materials, your walls, the thick walls, your windows really define your space. So here's the top 10. Small buildings, airtight construction, solar orientation, a well-insulated building envelope, mass material inside to store your energy, managing ventilation, solar heated water power, and then optimized technology. Of course, we want to be a smart homeowner as well. So here's two examples, a tiny house and a big overbuilt house that costs way too much money and therefore use too much energy and so forth. In China, they built these straw bale homes that are so energy efficient that they reduce the energy needed to run these buildings by about 2/3. And that, and since they burn coal in China, and this is in one of the coldest parts of China, Heilongjiang, these straw bale buildings actually reduce, save 1/3 of the annual income of these people that live there, so they can actually send their child to school, to college. So from farmers, they can become, technology experts, I guess, right? Let's see. There we go. And in this house example, this is a beautiful little cottage in Tacoma Park, Washington, and it was added onto and salvaged and turned into a beautiful house for a family with 5 children. Airtight construction is really important so that we can control our ventilation. You can see that in a typical home, there's many opportunities for air leakage in between the combining of all these various materials: doors, windows, attic, roof, ventilation. So we want to seal our air leaks. One great thing about the monolithic wall of a straw bale building is that it's really monolithic and there's not really a way for air to leak, only around the windows, doors, and so forth. Orientation is really critical. We want to orient our buildings to the winter sun so we can take advantage of the passive solar energy. And of course, daylight. And with straw, you're insulating your walls, but you also need to have a well-insulated foundation and ceiling as well. This particular chart is hard to read, but basically we're talking about abating carbon emissions here. And, sorry, let's see if I can go back. There we go. And, whoops, let's see. There we go. The number one thing to the lowest cost abatement of carbon emissions is insulation improvements, according to this calculation by the McKinney Institute. This is that architect I was mentioning earlier, Werner Schmidt from Switzerland. This building has no heating system other than a wood stove, in which case they say 1 banana box of wood to heat it in the wintertime. This is a climate where they get 10 meters of snow in the winter, and but they have a lot of sun in the mountains there, so they can solar heat their house. You can see also that there's very few windows on the west and the north, but there's a huge amount of window glazing on the south. You also want to be able to control that glazing, so you want to be able to lower the shades when you have too much sun or when it's dark outside and you need to conserve. And in this case on the right here, there's a skylight, skylid that opens and closes automatically. And this is another type of insulation that I think Athena mentioned earlier today, rice hulls in a place where they grow rice. This is happens to be in Louisiana in the south, the US South. They are very appropriate. They're about R3 per inch, And in this unique building, these rice hulls are insulating against the heat and doing a very, very good job of it in this traditional styled home. And of course, straw, which can be used as a structural material as well as an insulating, or I like to say outsolation. When you put your straw in your outer walls, and your mass material on the inside. Over here to the, over here, this is a wall in Germany. So in a wet climate, like you might experience here, where you might get major weather coming off the ocean, you can utilize this kind of a shiplap siding to protect your bales and you protect your plaster, especially if you're using an earthen plaster. I'd like to say Straw Bale building has nothing to fear from the big bad wolf. And there's, many reasons already mentioned why we like to build with straw bales. One of the greatest things is how quick they go up, and that's when we built our first building. It was a greenhouse, and we did a workshop, and we got all the bales done in a single day, and 2/3 of the plaster done on the outside the next day. So, and then we had a party. So I was hooked. It was so much fun. I decided I had to do more. And but it is challenging to get through the building codes, and you can't always find those straw bales when you want them. So that is something that owner builders or architects, builders really need to overcome. You're probably aware, but bale homes were invented probably independently a number of places, but we generally accredit it to the sandhills of Nebraska, which is about in the middle of the US, and the baling machine was invented in the 1870s, and so not too long after people started building homes in this particular climate, the soil was too sandy for sod homes or adobe, so people built with what they had available. They had rolling grasslands, and they started building with bales. And this is one of the original homes, 100 years later. That's the same. Yes, that's the same house. Mm-hmm. Yeah, and then these are two other historic straw bale buildings in the U.S. One of them is a church. It's a load-bearing 2-story church, and the other one, let's see, I'm trying to master this. Yeah, so in Arthur, Nebraska, and still standing today as a museum. And this is also a museum in a very hot, humid climate in Huntsville, Alabama, with a siding material and so forth. It's still operated today. Oh, and this is our straw bale greenhouse, and where we live in the southwest part of New Mexico. And I bought this lodge thinking I was going to, make movies here and so on. And in the end, but I found it was really hard to heat. So when I heard about straw bale building, I thought, oh, I'll try that. And so we built a greenhouse out of straw bales, and as I mentioned, it became my soapbox, and I started traveling, and that I found my tribe, which includes all of you here today. So bales can be used structurally, or they can be used in an infill situation. To the right are some bales being used in China, where they really like brick homes, and that seems to be the right, the affluent thing to do is to build a brick home. So this was a compromise to build structural brick with infill bales. And there's Werner Schmidt's building again in Disentis, Switzerland. He likes to build with the jumbo bales. The R value, I know it's not, I'm not sure how it translates to New Zealand R value, but the R value in these 4 foot wide bales is 113, which is, you know, yeah. Anyway, he says it's 3 times the passive house standard, which is one of the highest standards, you know, in the building codes. He designed that claw to lift the bales. And here's a building going up. And that straw was harvested just, I don't know if you can see in the background, this is that building going up, and here's the straw where it came from, right in the same neighborhood. And in Europe, a lot of people will use bales in the ceiling as well. So they'll design their ceiling loads to accept a bale, and then they will plaster them with clay, because you definitely don't want to leave an unplastered bale in your building. Plaster is really essential to reduce the potential for fire, you know, and in the ceiling, that's the last place you want to fire. This is, again, another Werner Schmidt building in Switzerland. There's actually a motorized shades here, so you can press a button, and if it's too hot in there, you can just lower the shades, or if it's too cold, you can lower the shades. This is a home near Tucson, Arizona, and it utilizes rammed earth, which is a beautiful, beautiful wall system, but also bales up here. So, you know, the combination of insulation and mass can be used, you know, in many different ways. And of course, clay plasters. Those are, not only are they great thermal storage and dirt cheap, but they also, in the School of Baubiology in Germany, they are considered the best kind of plaster for human health, because they also are hygroscopic, that means, or hydrophilic, that means they love moisture. So they safely store our excess humidity and clean out, and can also help to clean our air as well. Of course, you can have many different colors of clays. You can collect them locally, and they can also be used for floors. I don't think that pink clay is actually a local color. I think it's a fake color, but a lovely floor anyway. Now, windows are really important for ventilation, and to manage your ventilation. They also provide views, you know, light, heat, view, and ventilation. So you want to make sure that your windows you're going to capture your natural breezes. That's an important thing to consider when you're designing your windows, and of course your views. In Europe, they have these really terrific windows and doors that are, I'm sure, quite expensive, but they really are wonderful to manage. This is the outside here, so you know, at a touch of a button, you can close them off, and also, but you can also raise them out. And then these are doors, tilt and turn, so you can open them for ventilation, or you can open them as a door. It's really a great design. And one strategy that is very permaculturist is to grow a temporary shade. So shade really can keep your house cool in the summertime, and with global warming, we like to have more plants and shade is one way to keep cooler. So you can see here, these are some grapevines growing up. So in the summertime, they're going to provide shade, but then in the wintertime, they're going to drop their leaves and then allow the sun to shine in. And oh, by the way, they're edible. And a green roof is a rather expensive way to go, but in an urban setting, I think green roofs can offer a lot of positive benefits. They are a place, of course, you can grow something, but it helps to keep your buildings cool, and it helps to manage rainwater and even purify the rainwater in a city setting. So I think that they're very useful, you know, depending on your location. And using the sun to provide your hot water is a real natural thing to do. And you can use that hot water oftentimes in radiant heating, radiant floor heating, radiant wall heating, and of course, just in your domestic use. So it's really makes a lot of sense to incorporate that into a hybrid house. Here's a couple strategies for solar heating, solar hot water heating. This one here is this is like providing shade, as well as it's, you know, again, a permacultural strategy. You're providing shade, but you're also collecting hot water here. And here's a couple hot water heaters here in China. Of course, photovoltaics are, you know, on everybody's mind. We can collect sunlight for the energy, and of course, power our iPhones and our Teslas. So I see a couple Teslas around here. That's really exciting. And everything else that our TVs. And now, when you're way out in the sticks like this place, well, you might need to use batteries. And of course, we can choose energy-saving appliances and technologies. And know when to turn them off, too. Other ways to save energy are these masonry stoves. So there's you know, many different ways to have a masonry stove. Probably this is more appropriate here in New Zealand on the South Island, where it's going to get a lot colder than here on the North Island. But these are some strategies that these are a couple examples of masonry stoves from Europe, and here's some really low-tech masonry stoves. You can cook on them as well. Let's see. There we go. And this is in China. This is called a Kong, and it's a really clever system that they use in the Great Wall of China, and they've been using for many centuries, where they cook on this stove, and then they have two chimneys. One of the chimneys goes into this heated bed. So in the wintertime, the waste heat from this stove circulates into this bed platform, which is a mass material, and that helps to keep this building warm. And then in the summertime, they shift the chimney so that the waste heat goes directly out and doesn't overheat the house. And this is an example of two different types of energy systems. This is your geothermal at a cost of tens of thousands of dollars, and this is, you know, a couple $1,000s to put in these just your basic hot water heating systems that are actually a backup to a solar heating system. So you know, yes, geothermal is great when you have it like you do here in New Zealand, and you can tap into the natural hot water. But I'm not a big fan of using this all that technology to, you know, get a few degrees out of the earth. So this is I guess it's my thesis here. Let's be smart homeowners. I'm not that into smart homes, but we can be a smart homeowner and understand where our energy goes and make some sensible decisions. That's nothing new to a Kiwi, I'm sure. And this is one of my favorite houses because it's so well designed, and it was built on an urban lot. They took down a small building. They reused as much as they could have. They oriented the building to the winter sun, and they use both solar hot water and photovoltaics. They collect the rainwater. They have a landscape that's filled with natives, and their utilities average about $10 a month, including their meter reading fee. Oh. Which way is south? To the right, where the panels are facing. Yeah, yeah. And of course here you face it north, obviously. And so, I don't know what time it is, but this is the end. So there you go. Perfect? Oh, great. Thank you. It's all logical, right? Yeah. Oh, go ahead.
This may be a basic question, but you're talking about the earth cluster as thermal mass.
Yes.
I was just wondering how much, how much thermal mass do you get from? Is there fairly thin layer?
It is a thin layer, but when you imagine it's all over your house, right, on all the walls of your house, that adds up to quite a lot. It's a very, so it's quite a lot of mass. And one of the favorite California architects that I follow, David Arkin and Annie Tilt, they talk about it as distributed thermal mass. So it's actually, rather than just one big thick wall, it's all distributed around your house, so that it actually works even better, essentially, than just one big mass wall. But your floors, if you might have a concrete floor or an earthen floor, that's mass. You could use mass adobe for interior walls as well. So there's lots of ways to get mass in there, and I think that's a very, when you, like say we're experiencing this building here, it's, this is not a good example because it's full of mass, but I think the wooden structures there, you can get, the sun will shine in, but it's not absorbed in any way because it's pretty much wood, and so the materials are not absorbing that heat, so that it's very easy for it to cool off again at night. And so I think the combination of insulation, or I like to say outsolation, and interior mass are really a very good design strategy. Any other questions? Well, thank you very much for your attention. Appreciate it.